Have you ever wondered how rockets manage to break free from Earth's gravity? Or why we compare difficult things to rocket science? Well, rockets are the key to exploring the universe, and understanding how they work is the first step in answering these big questions. Rockets are amazing because they do something incredible. They escape the Earth's gravity and reach outer space. But what does it take for that to happen? To leave Earth's gravity, a rocket has to reach something called escape velocity. This is the speed needed to break free from Earth's pull without falling back down. For Earth, that's about 11.2 kilometers per second, faster than a bullet. So, how do rockets actually work? The secret is in Newton's third law of motion. For every action, there's an equal and opposite reaction. Imagine you're on a skateboard. If you throw a ball forward, the skateboard moves backward. A rocket works the same way. When it pushes hot gases out of the back, the rocket moves in the opposite direction. Inside, the rocket is an engine that powers this whole process. A rocket carries two key materials, fuel and oxidizer. Fuel is the energy source, and the oxidizer is what allows the fuel to burn, even though there's no oxygen in space. When the fuel and oxidizer mix, they ignite and create an explosion. This explosion releases superheated gases, which are then expelled through the nozzle at high speed. And that's what gives the rocket its thrust. Rockets are powerful, but sometimes they need a little extra push to escape Earth's gravity. That's where thrust boosters come in. At liftoff, rockets are heavy, carrying their fuel, payload, and all their equipment. The main engines might not generate enough force to lift the rocket on their own, especially for larger missions. Boosters help by adding extra power to get the rocket off the ground and through the thickest parts of Earth's atmosphere. With the bottom stage of the rocket complete, let's move on to explore the middle stage. Unlike the bottom stage, which uses dense and powerful fuels to escape Earth's gravity, the middle stage focuses on lighter and more efficient fuels. The middle stage commonly uses liquid hydrogen, LH2, combined with liquid oxygen, LOX. Liquid hydrogen, LH2. This is one of the lightest fuels available, which helps reduce the overall weight of the rocket. Liquid oxygen, LOX. This acts as the oxidizer, enabling the hydrogen to burn and produce energy. This combination is incredibly efficient and produces a lot of thrust with minimal weight, making it perfect for this stage of the flight. The middle stage plays a vital role in bridging the gap between Earth's atmosphere and outer space. With its lightweight fuels and efficient engines, it ensures the rocket stays on course for its mission. Finally, we've reached the top stage of the rocket, the section responsible for completing the journey into space and delivering the payload to its destination. The most important job of the top stage is to deploy the payload, whether it's a satellite that will orbit the Earth, a space probe heading to distant planets, or even a spacecraft carrying astronauts. And there you have it, the basic workings of a rocket. So next time you look up at the night sky, remember the incredible journey that rockets take to get there. This is just the beginning of humanity's adventure into the cosmos. Thank you for joining me on this journey. If you enjoyed learning about rockets, don't forget to like, comment, and subscribe for more amazing space science content. See you next time.